when we're working with square roots, we have to deal with the fact that there is something under that we need to pull out. So if you have a square root of 25, that's simple. You just do 5. A square root is an operation. Once you complete the operation, the square root goes away unless there's something that stays under it, meaning that could not be taken the square root of. So if I had something like a square root of 25, when I do that, it becomes 5. The square root disappears. I say this because it's quite frequently, especially if I do like the square root of 16. People like to put the 4 under a square root. It's like whenever you can take the square root of the next piece, they don't want to stop. Once you take the square root, it's done. Now, there are times where it's not a perfect square, where it doesn't come out completely perfectly. So we are going to have times where we need to simplify the square root. There's going to be something left behind. So if we have the square root of 216, we need to first figure out what are the factors. And when we try to figure out what the factors are, the easiest way I have found is if you work through the primes. And the primes that you'll need to focus in on are 2, 3, 5, 7, 11, 13. You might write these down. 17 and 19. So 2, 3, 5, 7, 11, 13, 17, and 19. If those do not work and it's not a perfect square, more than likely, I'm not going to make you simplify it any further. More than likely, I've never put a question on the test where one of those could not factor out of it. That could not be unless it was a perfect square. Does that make sense? So perfect square, you can use your calculator to help check for. But other than that, those numbers will help you get it simplified down to where you can work with it. It may end up with bigger factors, but you're simplifying it down with we'll be able to work with those. I always start and go up numerically. So start at 2, then go to 3, and so forth. And that way it keeps it all grouped. Stay with, did you notice any of those, none of those were complex numbers. None of those were like 6s, where there's 2 numbers that create it. They stay with the prime because when you're factoring, you're going to see the patterns and what can come out easier. Some of you are great with numbers, and you're going to see number tricks. Once you start seeing a pattern that works, so you might see a perfect square that can factor out, that's fine. And I'll show you how you can work with that. So let's look at 216. What's it divisible by?
2.
And I use the upside down division to show my work. It keeps it organized. What's 108 divisible by?
2.
What's 54 divisible by?
2.
What is 27 divisible by?
3.
What's 9 divisible by?
3.
And so because we're working with square roots, we are looking for groups of 2. So when we're looking for groups of 2, I'm going to come back in here. I have a group of 2 2s, and I have a group of 2 3s. So I'm going to write down one of those 2s and one of those 3s. We have things that are left behind, though, now. We have this 2 and this 3 left behind. It's going to go under the square root. So we'll end up with a square root of 2 times 3. And so we end up with 6 on the square root of 6. as your answer.
So do you just have like the 2 and the 3 others just like listed?
Because they don't have a partner. The ones that I highlighted that don't have partners stay under the square root. Because basically what we did is we had the square root of 4, this 2 times 2, times the square root of 9, times the square root of 6. We split it apart. I don't make you show this step. That's what we're doing, is we're factoring out the perfect squares. And they simplify to 2 times 3 times square root of 6. Is you can break apart a square root by multiplication factors. And we're pulling out the perfect squares and taking the square roots. And so if you look for a set of them, 2 times 2 creates 4. 3 times 3 creates 9. And so if you start seeing I can divide by 4, just remember you're taking the square root of 4 and you're putting a 2 on the outside. So those that are good with number tricks and want to go with the perfect squares looking for those to come out, that's what they would look like. Let's do 392. We're going to do it the same way. Looking for things that can divide into it. 392. What's one number that can divide into it?
2.
2. Leaving us what?
196.
What divides into 196?
2.
Leaving us?
98.
What divides into 98?
2.
Leaving us?
Sorry.
That's okay.
Like 46, 47. 49.
What divides into 49?
3.
No.
7.
7 and 7. So what do we have that can come out? We have a set of 2s and we have a set of 7s. So 2 times 7 comes out. What stays behind is just that 2. So on the square root of 2. So we have, the answer is 14 on the square root of 2. Now, people will do their factoring different. I like this because it keeps it organized and it's easy to find. You're not having to, so you can use a factor tree to do the same thing. This keeps your work organized. If you're doing a factor tree, you can use bigger factors to split it apart and just go down to your primes. So what's different? There's a negative and a number in front. He just hangs out. So this negative 6 just hangs out and waits for us to find other things to join it. So we're going to look for the factors. So we're going to take 200 and simplify it.
2.
Divides by 2, leaving us 100, which is divisible by,
2.
which leaves us,
50.
which is divisible by.
5.
Okay. Let's do the 2 first, just to complete the 2's out. It's okay the 5 is true, but I like to keep my work organized and keep all the same factors together. And now 5 and 5. So it's okay if you would have put that 2 up there, or that 5 up there, it would have worked the same. You just would have had your 2's disjointed. And so let's see, what groups do we have? We have a set of 2 2's and a set of 2 5's. So that means I have a 2 and a 5 that join outside with that negative 6. What stays behind? The 2 doesn't have a partner. He stays outside under the square root. And so my outside number is going to become 2 times negative 6 times 5. So negative 60 on the square root of 2. One more and then I'll let you work on your work. And so let's find this one. I want you to do quietly in your head or on paper. Y'all should have ended up with 56 on the square root of 7. So we end up with factoring out to have 3 sevens. We have a set of sevens that can come out, leaving behind a 7 under that square root. Then we have the 8 times 7 multiply on the outside. The other portion of tonight's homework is going to be working with, you're going to have to find the discriminant. That means you're starting at that b squared minus 4ac. You're just plugging in those numbers. And if this was positive, how many real solutions did it have?
2.
If b squared minus 4ac is negative, how many solutions did it have? No real. And if it was 0,
1.
only thing that we're going to do extra than this is I'm going to make you simplify what will be under the square root if it happens to be this scenario. So now that goes into the square root for the quadratic formula. You're going to simplify that number to what number would you put in that spot. Does that make sense? So you're trying to figure out what number would I put into the spot here in the quadratic formula. So with the square root,
You just find the square root on that?
just find that square root. So you simplify that square root.
So you only find a discriminant?
Just the discriminant, and then if it happens to be 2 real solutions, then you take it one step farther and also tell me what would that simplified square root look like. Would it be something like 5? Would it completely go away? Or would it be 5 on the square root of 2? What would it be? That's only for this scenario. These other scenarios you're not having to simplify.